Okay, good evening everyone. Assalamu alaikum wa rahmatullah. Today lecture or session number 6 in the oil and gas industry. Today we speak about the midstream. We almost finished the upstream sector. In 5 sessions we studied the upstream. We spoke about the well, the drilling, the all exploration required in the upstream sector. So always be with me on this sequence. We have upstream, midstream, and downstream. So today we will speak about the midstream. In the midstream section, today we will speak about the gathering of the gases from the well, how we gather it. We speak about the gas plant. In the midstream, they are doing some plant and gas processing. And we'll speak about the pipeline. The pipeline is a way to transport this gas to the refinery. Then we'll speak about LNG, liquefied natural gas, how they liquefied and why they need to liquefy the gas, and how they transport and store and regas again this natural gas. As I told you, we finished the sector related to the upstream, and we will speak today about the midstream. So this upstream, including exploration, including the drilling, this finished already. So today we will speak about the midstream. Okay, Mr. Fol, you want to speak? Yeah, you can unmute.
Yes, it's just I don't want to forget it because I have some people who ask if it's possible before the lesson you share maybe 1 or 2 days before the topics that will be that we will see in the lesson in order they prepare the
No problem.
subject.
Hand the book.
Yeah, this is like the previous slide. You can just send the previous slide.
This one?
This one, yeah. To say, okay, for the next session, we will see these concepts in order they know what we will talk about and they prepare the session.
Okay.
I think it will help to be more reactive also.
Okay, sure.
They will do their research and if they have questions, so they will ask them during the lecture.
Okay, I agree.
Thank you.
Okay.
Thank you. Yeah, that's all. Thank you.
Okay, you are welcome. No problem. We can do so. Okay, so today we'll speak about the midstream, as I told. In the midstream facility, if you can see in this photo, we have processing plant, we have any natural gas, liquefied natural gas, we have the gas gathering, and we have pipeline in the midstream. So this midstream is mainly about how they process with gas processing, gas plant, and the pipeline that's to carry and transport the gas, and gas manifold and valve manifold, gas station, compressor station. This is all in midstream sector before to go to the final refinery or transport product for the downstream for the market. This again a photo for midstream sector. As I told you, the gas that is being explored or extracted from oil, it is not a pure gas. So they have some impurities, they have some material or some component like water, like other components that it's not useful. So they cannot transport immediately the gas that's coming from the well to the market or to other country. So they have to do some processing. This is mainly the midstream, is to do some processing to the gas that's coming from the well, because it is not pure gas. It is not a pure gas. And this processing consists of many items. They are removing nitrogen, maybe they are removing water, they are removing acid. So this removable of this component is happening in gas plant in the midstream sector. Then after this processing happens, then it will be transferred through pipeline. So this is what I just explained, that the raw natural gas from the well consists of methane as well as many other smaller fractions of heavier hydrocarbon and other component, as I said. So the gas has to be separated into market fractions and to be treated to the right specification to protect equipment so it's for contaminant. So they have to have some specification of the gas, and to meet this specification of the gas, they have to do some treatment or gas treatment before they sell to the market. So this is all from midstream sector. Here, the upstream, if you see this drilling well, and we all study this one, so either we have natural gas or we have oil. So either we have natural gas or we have crude oil. The natural gas is go through treatment or gas treatment. The dry natural gas can go easily to the pipeline and then storage. The wet natural gas, they have to do with gas compression, gas processing, because they have unprocessed natural gas. They have some component, so it needs to be processed first. So after completion of the gas processing or gas treatment, pure gas will go here to this section, then it will go to the market without any problem. This also happens with the crude oil. So we either have from the well, have either gas or oil. This also happens to the oil, the same philosophy. So what's meant by gas gathering for the midstream? It means that they have many flow lines connecting together to the well pad. This actually to gather all the gas from the well head and from the well source, and it will go to the gathering station. This is mainly applied in the first step after completion of upstream and starting of downstream. They start to gather the gas, connecting together. They have very big equipment like a launcher, and this launcher is an equipment that allow the gas after gathering to be connected into this launcher, then it will be connecting to the pipeline. So here another photo of how they gather the gases from the oil. Here gas gathering of pipeline from the wellhead. This is all by connecting from wellhead, and all of them are processing of gas gathering. Before to go to the processing facility, they have to gather the gases or pipeline. So here another photo. Here is a gas production from the well, from exploration. After exploration finish, then this pipeline for gathering. After that, they will go to process the gas. So why we need to process the gas? We are now reached to this stage, gas processing here. For the next slide, let's speak about it, gas plant. As I told, this gas is not pure. It's not pure. So they cannot use it. They cannot use it. They have to remove the unwanted component. There is unwanted component from the well that is already exist in the ground, such as hydrogen, sulfate, carbon dioxide. These gases is called acids. So they want to remove it before to sell to the market. All right. So this is called gas treatment. Gas treatment is also in the gas treatment. They also do calibration Why they need to do calibration? To meet specific requirement for the market, specific requirement. They need to have some specification of the gas, and to do this specification, they have to do calibration. So again, the gas treatment or gas plant is merely to remove the unwanted material like hydrogen, water, sulfate, carbon dioxide, nitrogen. All of this unwanted material is not required, and it is not meeting the gas specification required in the market. So they have to remove it and to do calibration in the gas plant or gas processing to meet the gas specification requirement. So this is the type of product after processing, product of the gas, natural gas. We have either natural gas, have liquefied petroleum gas. This liquefied petroleum gas that we can use in the house, in the home, in the kitchen mainly, in the cook for cooking. This liquefied petroleum gas is used in our home, in our house for cooking. We have also liquefied natural gas. Liquefied natural gas. We have also compressed natural gas. So all of these products is being finalized after the gas treatment. After you finish the gas plant, you have many products. As I see, natural gas, it is under pressure. We have liquefied petroleum gas, it is mainly propane and butane. We have liquefied natural gas, is being under very low temperature. It reached to minus 162 temperature to be liquefied for liquefied natural gas. Then we have a compressed natural gas, it being 180 to 200 bar for the pressure. And we have condensate liquid and oil and other heavier fractions. So this is another photo of the product that's being processed from the gas plant. As I told, we have this all natural gas, we have methane. This methane, it can be liquefied to be LNG, liquefied natural gas. We have ethane, we have propane, butane, isobutane, this all liquefied petroleum gas. So LPG is liquefied petroleum gas. LNG is liquefied natural gas. NGL is natural gas liquid. Natural gases liquid. Natural gasoline and bentanes plus. So this is all the product as you can see in this photo. The LPG, this one is used in our home, in our house. Compressed natural gas, this also used in this small vehicle or small motorcycle, or they call it in our country, tuk-tuk. I don't know what's name in your country. So this is used compressed natural gas. This is BNG, this is liquefied natural gas, and extra. BNG is petroleum natural gas. So this is also another photo of removable of the unwanted material. The unwanted material that's going to be extracted from the gas. Like they want to remove here the acid removable. They want to remove the acid from the gas. They want to remove the hydrogen or the water. So they have dehydration. This dehydration process is to remove the water from the gas. And this acid gas removable is mainly to remove the sulfur and all the acid from the gases. This mercury removable is to remove the mercury from the gases. This nitrogen is to remove the nitrogen. And then they can reach to the pure gas, sales gas here at the end. They have pure gas after all of these cycles of removable of unwanted material. Started from the well here, then go to some mainly processes, removable of water, condensate, removable of acids, removable of water again, removable of mercury, nitrogen. Then they have pure gas that can sell to the market here. Okay, let's have some video that explain the process of the removable of this.
Is to make knowledge easier because students have
I want to ensure that I'm sharing my screen. Is the sound okay now?
Lack on them. So only 8% of the energy which is
Liquefied natural gas technologies from Linde are setting new reliability and efficiency benchmarks.
My name is Mark Scheer and I'm Vice President for Business Development and Sales for LNG and gas processing plants. The heart of every LNG plant is the liquefaction technology, together with the main cryogenic heat exchangers.
Linde's innovative Limum technology, a single mixed refrigerant process, was selected for a 1.5 million tons per annum LNG project in Russia's northwest region. This is the second largest LNG plant ever designed and executed by Linde.
A 1.5 MTPA LNG plant. That means you have to engineer, procure, deliver, ship, and finally stick together probably like about 3 million parts in less than 3 years. That's a huge challenge. My name is Matthias Brüntrup and I'm a project director.
Pipeline natural gas is fed into the plant. Various impurities and heavy hydrocarbons are removed first. Then the clean gas is liquefied using Linde's highly specialized and efficient Limum technology.
it's like a big fridge in your household, only much larger and colder. My name is Heinz Bauer and I'm Department Head for Conceptual Design Natural Gas Plants. The Limum technology has a minimum equipment count. It is very easy to operate and it has a pretty low energy consumption for this size of plant, which amounts to only 8% of the energy which is brought into the system by natural gas.
In this plant, the gas is liquefied in a coil-wound heat exchanger. This equipment is custom fabricated by Linde and uses a mixed refrigerant to.
We have designed and fabricated two full aluminum coil.
Because we are speaking about now liquefaction of natural gas, which we will explain next in the next slide. So let's first understand the topic, then we can share the video how they do liquefaction of natural gas. So pipeline, now they finish the processing of gas, they remove the nitrogen, they remove the water or unwanted material, they remove everything is not required. Then it is time here to transport. They need to transport this pure gas or this gas from the gas plant to the market, to the downstream area. So this is how they transfer it, how they transport using pipeline. They are using pipeline. So this mainly the pipeline purpose of why we are using pipeline is mainly for transport the gas after being treated from the gas processing plants. The pipeline actually have many components. We can have driver, compressor or pumps. Compressor or pumps. What is the difference? Why we are using compressor and why we are using pump? It depends on the source. If we have a gas, so we are using compressor. And here, this is the compressor station. Here, or pump station. When we are using pump if we have liquid Again, this is very important. I may ask this question. Why we are using gas compressor? We are using gas compressor station because we have gases, so it should be compressed. We cannot pump gas. We only pump liquid. So we are using compressor station for gases. What about pump? Pump station only use if we have a crude oil or liquid. So only the pump station used if we have a liquid to pump the liquid to the other destination. So this is only required for the compressor and pump station is to increase the pressure that's required to reach to the destination. So you have a source and you have destination, and this pipeline is it is very long. It's reached many countries. It has maybe length of thousands of kilometers. So the pressure is dropped every time. So you have to have pump station or compressor station to increase the pressure of the flow so that it can reach to the next stage until it reach to the destination. So this is very important. This compressor or pump station is to increase the pressure of the flow so that it can be reached to the destination. We have something called big receiver and launcher. This launcher and receiver is very important. The launcher will be on the first step or on the upstream of the flow, the launcher. The receiver will be on the downstream of the flow at the end of the pipeline. So at the beginning of the pipeline, we have a launcher device with a big launcher. And at the end of the pipeline, we have a big receiver. This is a small facility we will explain in the next slide. So this pipeline needs to be controlled through SCADA system. So here, this is all the pipeline. We have many devices on the pipeline through all the way of the pipeline. This is, by the way, above ground pipeline. So the pipeline can be above ground, as you can see, or it can be underground, or it can be what? Underground. So the pipeline can be above ground, as you can see in the photo, or it can be underground. For this one, how they control it, they have, as I told, it is long distance. So they control it, all these instruments like pressure transmitter, temperature transmitter, flow transmitter. This all instrument, FT, PT, TT, it is to measure the flow, measure the pressure, measure the temperature. This measurement is reached to a remote terminal unit through SCADA system satellite. So they can use it in the SCADA network to monitor all the pipeline, all the devices. They can easily shut down the valve here or control the flow or increase the pressure by using all these devices. It is monitoring through the control room. This is another also photo, typical oil pipeline SCADA system architecture. So they are using this through SCADA system to monitor the devices, to where are they measure the pressure or temperature or the flow as well through SCADA system in the main control room. Okay. So here's what we call it the pipeline terminal. This is the pipeline terminal. This is include the launcher or receiver as a minimum requirement, as I told before. This is scrubber launcher or scrubber receiver. It has a pig, and this pig is it is inserted inside the pipeline for cleaning the pipeline. So how we remove this pig, this small pig, we remove it through the big launcher or big receiver. So this is the launcher and this receiver. This is a typical photo of the launcher and receiver. And here it is installed on the pipeline. If you can see here, for example, if this is the pipe launcher at the start of the pipeline, So it is installed like this way. To control the pipeline, it's required for big to clean the pipeline. So the small big will be entered from here, and this all opened until it reached to clean the pipeline. So then it will be removed again from this launcher or receiver. We have also in the pipeline, we have, as I told before, we have the compressor or valve station. So we have a compressor station. So since we are speaking about gas, so we have to have compressor station. So this is typical of compressor station. It is exist actually above ground. It is above ground facility. So this is a compressor station, and this compressor station is required to what? To increase the pressure. To increase the pressure, because what happened? The pressure will drop along the pipeline. So along the pipeline, since the pipeline is a very huge length, so the pressure will drop along the distance. So to increase the pressure again, you have to have compression station. This compression station is required to increase the pressure until to reach to the final terminal or final destination. This is also an example of the configuration of pipeline, and this is here the compressor station. And we mainly this compressor station to be to have a power to drive this compressor station, and this is very important to increase the pressure. And this is the big launcher or receiver station here. This is valve station, and this is metric station. All of these component is installed on the pipeline to monitor and control the pipeline. It is very important to easily transport the gas or liquid through the pipeline. We have to have big launcher or receiver. We have to have compressor station for gases. We have to have pump station for liquid. We have to have valve station. This valve station is group of valve. Either isolate or shut down valve is for the safety of the pipeline. If, for instance, the pressure increased dramatically, so we have shutdown valve to shut down the flow or to stop the flow from increasing or from passing. So we have to have valve station here. And we have to have metering station. This metering station is to measure the flow. Metering mainly is to know the flow required before we sell to the market. So as I told, the valve station is very important. So we have to have many group of valve here. This valve station is to allow closure of the flow, to monitor the flow. And also it's required also this valve station is operated remotely. So we cannot operate this valve station from the field. So it is operated remotely by remote control through the control room by using the SCADA system. So we have to monitor this pipeline remotely. This also another photo of the pump station. So if we have a pump instead of compressor, this only for what? For liquid, for the liquid. So for the liquid, mainly for the crude oil product, we have to have pump instead of compressor. And this is the pump station photo through all the pipeline. So here is the pipeline underground. We have pump station to increase the pressure. So this is also connected again to the pipeline above ground. For example, if you have water pipeline, so this is a configuration of the pump station of the pipeline through the pipeline. And this is pump station is not only one. Maybe it can have different pipe stations. Maybe pump station number 1, pump station number 2, pump station number 3, along the pipeline until it reach to the final destination. We have to have pump station to pump the liquid to increase its pressure. This is also another photo of the pump station. Instead of compressor station, we have pump station, we have valve station, we have tank at the end, and we have processing plant at the start. So this is how they are using these components through the pipeline. Again, we have to have pump station for liquid or compressor station for gases. We have to have valve station for monitoring or isolating or shut down the flow. We have to have a tank at the end to store the liquid. So let's see one video again about natural gas compressor station. How the processing is mainly working and how it works actually in the real industry.
In this video, we're going to follow the pipes on a typical natural gas compression station and explain how each piece of equipment works. This is the inlet pipe on the compressor station. The pipe coming from underground carries natural gas from many different sites. At this point, over 500 well sites are flowing into the station with a flow volume over 45 million cubic feet per day. Also, leading into the main inlet on this site are two pig receivers from two different lines. All of the process fluid that the pig is pushing through the pig launcher moves into the main inlet pipeline with the natural gas. On the pig receiver, the pig trap closure is where an operator would remove the pig from the line. The pig sig will indicate that the pig has arrived. Next on the pipeline is an emergency shutdown valve, or ESD. If someone were to press an ESD button, or if the system were to overpressure, this will shut in the system. In the event of an ESD closure, the bypass line will be used to slowly increase the pressure to resume operation, so the system is not pressurized too quickly during startup. During regular operation, natural gas is coming into the station at 40 to 45 psi. When leaving the station, the final pressure will be between 1250 and 1300 psi. The slug catcher is designed to handle the large volume of fluid that the pig pushes into the station. It also helps to separate water and hydrocarbon liquids that may condense out of the gas stream as the gas cools and moves through the pipeline. The large amounts of hydrocarbon liquids and water that the pig pushes into the slug catcher travels to storage tanks on this location. At this point, a site may use an emulsion breaker to aid this separation process of resources. After the slug catcher, you may notice more pipes with empty end connections. This station is built to be modular and allow for other equipment to be added in the future if the producer decided it was necessary for increased capacity. After much of the initial fluids have been removed, the natural gas moves into a second vessel, a filter separator. A filter separator removes impurities such as pipe scale, water, iron sulfide, liquid hydrocarbons, compressor lube oil, and sulfur products from natural gas. A filter separator differs from a standard separator vessel in that it uses filter elements to remove contaminants rather than using mechanical devices and other principles of separation. For more on filter separator operation, watch our video specific to that vessel. This filter separator has a liquid boot design where the liquids fall into a lower portion of the vessel. This is a two-stage separator. In the first stage, liquids fall out and their levels are controlled by this level controller. In the second stage, when the gas passes through the filters, the liquids drop on the other side of the boot and are controlled by a second level controller. The gas then flows into the suction header and into the individual inlets for each compressor. This pilot is monitoring and controlling the suction of the compressor. The compressor operates most efficiently in a certain window of conditions. The suction control valve and the pilot prevent the compressor from going down on high or low suction pressure. After the suction control valve, the natural gas travels through underground pipelines into the inlet scrubber of the compressor that is located on the other side of a sound barrier wall. Large compressors like these are found at compressor stations where high volumes of gas are being gathered from multiple wells over a large area or from a large pipeline. These stations help move gas from one side of the country to the other. The size and number of compressors found at these stations vary based on the pressures, volume of gas to be moved, and the distance it must travel to the next station. You can learn more about the function and flow path of compressors with our other videos specific to that topic.
Okay, I think this now is good to know about the natural gas compression station and why we are using compression station to, as he mentioned in the video, to compress the flow or gases to the next station or the next terminal or destination to increase mainly the pressure of the gas. So let's go to the next topic about LNG, liquefied natural gas. All right, this is mainly methane. So the gas here for the liquefied natural gas is methane, CH4. C is carbon, H is hydrogen. So we have 4 of hydrogen and 1 of carbon. Its components together or mix it together to have CH4. And this is the methane actually. This is the natural gas. So this natural gas, they are doing what? Liquefaction. They change the phase of the gas to be liquid. So why they are doing this? Why they are converted the gas to liquid? This is mainly for easy to transport and store. It is easily for the liquid to be stored and transported. So imagine that they have to transport or store huge amount of gases, natural gas, and they want to transport it to many countries all over the world, overseas. So it is not possible to store the gas. So they change the phase to be liquid, so it will be easy to store and transport. Because the volume of the liquid is about 600 times the volume of gas. The volume of the liquid is 600 times the volume of gas. So they can transfer huge volume of this natural gas, liquefied natural gas, through all the distance. So this is mainly the purpose to do liquefied natural gas. And this is definitely using many processing of liquefaction. It's mainly as a bridge, as a fridge in our home. We are using or air conditioning. We are using compressor or condenser or heat exchanger. This is mainly to change the phase of the gas to liquid. Change the phase from gas to liquid. And at the end, it can easily store or stored in the tanks, insulated tanks. As you can see here, this is become liquid. The gas become liquid and can be easily stored in tanks, insulated tanks, as you can see here in the photo. So this is very important, the liquefied natural gas. Its carriers are used when the transport distance doesn't justify the cost of a pipeline. So here, they are using the carrier or the ship to transport this liquefied natural gas over the seas through many other locations to many other areas or many other plants or many other countries. They are using the ships or carrier to transport this liquefied natural gas with large volume of gases, of liquid actually, then they can reach to the destination. After that, they can transfer again the liquid to gas. Let's see this video and how they can doing the liquefied, how they transfer the gas to liquid.
The world's population is growing, and for many, living standards will continue to improve. As a result, global energy demand is expected to double by 2050 when compared to 2000. To help meet this demand, gas will form an increasingly important role. Natural gas is plentiful, and it's the cleanest burning fossil fuel. But some natural gas resources are in remote locations. Transporting the gas long distances by pipeline can be costly and impractical. The solution? We liquefy the gas by cooling it, which shrinks its volume for easier, economical, and safe transportation by ship. So how is liquefied natural gas produced? Natural gas extracted from the ground contains impurities, water, and other associated liquids. First, it is processed to clean it. It goes through a series of pipes and vessels where gravity helps separate the gas from some of the heavier liquids. Other impurities are then stripped out. The natural gas passes through a water-based solvent that absorbs carbon dioxide and hydrogen sulfide. These would otherwise freeze when the gas is cooled and so cause blockages. Next, any remaining water is removed, as this would also freeze. Finally, remaining lighter natural gas liquids, mainly propane and butane, are extracted to be sold separately or used as a refrigerant later in the cooling process. Traces of mercury are also filtered out. Now the purified natural gas, methane with some ethane, is ready to be liquefied. This happens in heat exchangers. A coolant, chilled by giant refrigerators, absorbs the heat from the natural gas. It cools the gas to minus 162 degrees centigrade, shrinking its volume by 600 times. This turns it into a clear, colorless, non-toxic liquid, liquefied natural gas, or LNG, that is much easier to store and transport. The LNG is kept in insulated tanks until it is ready for loading into a specially designed LNG ship or carrier. When the ship arrives at its destination, the LNG is transferred to a regasification plant where it is heated, returning it to its gaseous state. The gas is then transported via pipelines to customers, providing energy for homes and industry. Shell continues to help meet growing energy demand with clean.
Okay, so this is how they are doing this processing for liquefied natural gas. They cool the gases, they reach to the temperature minus 160 degree temperature. So after they remove all the impurities, they remove the water, because the water, if they cool the gas with water, so the water will be freezed, so it cannot help the gas to be transferred to liquid, so it will be freezed. It cannot be transferred to liquid easily. So they have to remove water, they have to remove impurities, unwanted material, nitrogen, they have to remove the acids, the sulfur from the gas. Then it will be pure gas. Then after that, only they can cool the gas to minus 60 degree to be liquid. Then after be liquid, it can easily stored in the tanks and transported through all the countries, through carriers, through ships, on the seas, or pipeline. So it can be easily transported. Then at the end, before the customer use the gas, it will reach to the end destination for regasification. So they change again the liquid to gas. They are heating again the liquid to change to gas. Then they can transfer this gas to the end user, to the market. So this is the end cycle. They are transferring these gases, this liquid to gas at the end. So the storage and at the terminal or LNG carrier is done is cryogenic tanks at atmospheric pressure. So these tanks actually are insulated. These tanks, the LNG tanks, is all insulated. but it cannot keep the LNG cold enough to avoid evaporation. So the LNG is stored as a boiling cryogen, which means that the liquid is stored at its boiling point for its atmospheric pressure, about minus 162 degrees Celsius. So after that, they have to boil it against the gas, boil a gas again to be transported again as a gas pipeline. So after the gas here is liquefied, this is the LNG from LNG ship. So this is a discharge line, is going to the LNG tanks, then going again to the recondenser or vaporizer. So it will have here heated again to a degree of 10 to 25 degrees Celsius to reach again to the gas mode or gas phase. So it will can be now gas processing to gas pipeline. So this is how they store the tanks, the LNG. This is our LNG tanks, cryogenic tanks. And this is the carrier. And this is the end user of, after they do the regasification, they change the liquid again to gas so that it can be easily used in the market, So let's see another video, and this will be the last before we finish our lecture today.
احجز فندقك أو تذكرتك بأفضل الأسعار وسدد على دفعات. حمل تطبيق المطار.
LNG, liquefied natural gas, LNG, is natural gas that has been cooled to at least minus 162 degrees Celsius to transform the gas into a liquid for transportation purposes. To understand why liquefying natural gas is important, we first need to understand natural gas's physical properties. Methane has a very low density and is therefore costly to transport and store. When natural gas is liquefied, it occupies 600 times less space than as a gas. Normal gas pipelines can be used to transport gas on land or for short ocean crossings. However, long distances and overseas transport of natural gas via pipeline is not economically feasible. Liquefying natural gas makes it possible to transport gas where pipelines cannot be built, for example, across the ocean. The four main elements of the LNG value chain are 1. Exploration and production, 2. Liquefaction, 3. Shipping, 4. Storage and regasification. At the receiving terminal, LNG is unloaded and stored before being regasified and transported by pipe to the end users. The demand for LNG is rising in markets with limited domestic gas production or pipeline imports. This increase is primarily from growing Asian economies and particularly driven by their desire for cleaner fuels and by the shutdown of nuclear power plants. The largest producer of LNG in the world is Qatar, with a liquefaction capacity in 2013 of roughly 1/4 of the global LNG production. Japan has always been the largest importer of LNG and in 2013 consumed over 37% of global LNG trade. The extraction process also has environmental and social issues to consider. LNG projects require large energy inputs for liquefaction and regasification, and therefore have associated greenhouse gas emissions. Spills pose concerns to local communities. There have been 2 accidents connected to LNG, but in general, liquefaction, LNG shipping, storage, and regasification have proven to be safe. LNG projects require large upfront capital investments, which can be a challenge in moving projects ahead. That's LNG.
Okay, that's LNG, and that's our lecture today. So we finished so far, dear brother and sister. Please let me know if you have any questions so far before we close our session. Before you ask, I will ask. Okay, so be ready for my question. Don't move. First questions. Okay. What is the difference between gas station and pump station? First question. What's the difference between gas station and pump station? Mr. Ba, yes, you can answer. Sorry, yeah, I allow you to speak, sorry. Yeah, you can speak now. Mr. Ba, you can speak.
Hello?
Yes, hello. Can you hear me?
Yes, I can hear you.
Yes. Mr. Ba, what is the difference between gas compression station and pump station?
So I have a question.
Yeah, go ahead.
Can I have the resume of the class?
Can you have what? The resume?
Yes.
What's mean by resume? You want to have the lecture, the topic?
Yes, yeah. Yes.
Okay, I will share, as I told with Mr. Mr. Hassan, I will share the content of the topic before every lecture, what we will study in the lecture, so that you will be prepared to know what is the content of the lecture, of the session, no problem.
Okay.
But Mr. Ba, what about my question?
Okay, can you repeat the question?
Okay, do you know the difference now between compression station and pump station?
Yes.
Hello.
Okay, what is the difference?
Compressor station
Yeah.
is a mechanism where the gas is explored or taken out by its own means.
No, I mean, when you are using compressor, when you are using pump.
Compressor is with without air, where we don't use impurities. It's a mechanism where we use to clean impurities.
No. This is okay. Let's ask someone. Yeah, before I will answer, maybe we can ask someone else to answer this. Who can reply to these questions? What is the difference between compressor station and pump?
I'm gonna try.
Yes. Okay. Go ahead.
I'm gonna try.
Yeah, Mr. Sik, go ahead.
Yes, the difference for compressor and pump station is for compressor is used for gas.
Yes.
Or pump station is used for liquid and crude oil.
Exactly. Excellent, Mr. Sik. So, Mr. Ba, have you heard the answer now?
Yes, what I'm trying to tell you, sir.
Exactly. The compressor is used for gases and the pump used for liquid. Okay.
Yes, is what I was telling you.
Okay. All right. So, Mr. Sik, why we are using compressor station or pump station? Why? Why actually? What is the function of the compressor station? Can you answer this, Mr. Sik, or we can ask somebody else?
Well, the compressor station
is
used to separate, is used to transform gas to liquid.
Compressor station to
transfer the gas to liquid.
No, not to transfer the gas to liquid. No, this is not the purpose. Okay. Why we are using compression station or pump station? Yani we have pipeline, we have huge pipeline, we have a distance, we have a long distance of pipeline. So why through the pipeline we have pressure station, compression station, or pump station? So Mr. Abdul Qadir, can you answer this question?
Can you repeat, please, sir?
Yes. Why we are using the compression station? What is the purpose of compression station? Why it is there? Let's ask the question in another way. If we don't have compression station, what will happen?
In fact, gas for transportation have to be compressed to facilitate the transport.
Say it again. For transportation, you are saying?
The gas is compressed.
Gas condensate?
To facilitate the transport.
Not really the answer. This is not really the answer. I need the exact answer. I need someone tell me why we are using compression station, why we are using pump station. Yes, Mr. Amadou Diallo.
Yes, I think the compression station used to increase the pressure.
Exactly. Exactly. Thank you.
Out of the liquid to reach the destination.
Exactly. Thank you, Mr. Amadou Diallo. Perfect answer. This is what I need to hear. So, dear brothers, please be focused. This is very important. The gas compression station or pump station is mainly used to increase the pressure to reach to the destination. Okay? So let me give you an example. I will give you an example. You are using your car. This is an example. It's not really a close example, but an example. You have a car. You need to travel from one country to another country by using your car. But without fuel station, are you able to continue? Or you need every time to increase the fuel so that you can reach to the destination? You need to increase the fuel, right? The fuel will decrease, will drop along your distance with your car traveling. The fuel will decrease, it will give you alarm. So the fuel will decrease, then you go to the fuel station or gas station to put a fuel, to increase the fuel. This is close example to the gas compression station or pump station. You have to increase again the power. Here the power is pressure. You need to increase the pressure of the flow to reach to the destination for traveling. So imagine that this gas or this flow is traveling through the pipeline. As you are traveling with using your car, this gas is traveling through the pipeline. So along the distance, along the journey, the gas need to be pumped out or compressed to increase the pressure, as Mr. Amadou said. Excellent answer, Mr. Amadou. Thank you so much. All right, last question. Okay, last question. Why we are using LNG? Like why we are using LNG? Why we need? What LNG stand for? Yeah, what's mean by LNG? And why we are using LNG? So anybody else? I asked Mr. Ba, Mr. Abdul Qadir, Ms. Amadou. Okay. Anybody can answer this question? What LNG and why we are using LNG? Yes, Mr. Ba, you can answer. Hello? Mr. Sik, you can answer. Mr. Sik, can you answer this question? What is LNG and why we are using LNG? Mr. Amadou Diallo, can you answer this one?
Yes, I'm gonna try.
Thank you.
LNG is a liquefied natural gas.
Yes, perfect. Why liquefied natural gas?
Yes, we use it to transport easily natural gas because the liquid form allow to reduce the volume of the gas.
Perfect answer. Thank you so much, Mr. Ahmad Diallo. Thank you a lot. So this is exactly the answer. Liquefied natural gas, LNG. And we are using LNG to transform the form of gas to be liquid. And why we need to change the form of gas to be liquid? Because it can be easily transported and stored as well. Stored and transported. And imagine that 600 times the volume will double. 600 from gas to liquid. Imagine the cost and the infrastructure. If you only transfer the gas, it will be 600 times doubled if you convert it to liquid first, then you transport and store. So 600 times the volume. This is huge, actually, investment. So it required to be transferred first to liquid, so it can be easily transported and stored and increase the volume, the amount of the gases. Thank you, Mr. Amado. I really appreciated your focus and your answers. Thank you, everyone. Thank you, Mr. Bah, Mr. Abdul Qadir, Mr. Sik. Thank you, Mr. Fool, Mr. Hassan. So thanks, everyone, for your attendance today. Please let me know if you have any question before we close our session today so far. Do you have any question? All right.
Please.
Yeah, Mr. Abdul Qadir, go ahead.
If you can come again for the summary of the class, please.
Summary of the class?
Yes. Just the title.
Oh, you mean, okay. You mean the content of the class? This one?
Yes, please.
Okay, so today we studied so far the gathering, the gas plant, the gas processing, the pipeline, the LNG. I will share this one in the WhatsApp, okay?
Okay, thank you.
You are so welcome, no problem. Okay, thank you everyone. See you later next time. See you. Assalamu alaikum wa rahmatullah.